Hello there. Welcome to this video testing Arduino Uno. Let's slide an LED. In this video, we're gonna first see the breadboard basics. Then we're gonna understand the circuit. We're gonna walk through the code and we're gonna see everything in action. Breadboards are very useful at the stage of prototyping, for testing devices, and for other electronic purposes. You can think of a breadboard as a pre-printed circuit board. It has pre-made connections for you. Let's take a look at the connections. A breadboard is divided into two sections. One is across the edges of the breadboard, so you can see the plus and minus right about here. So these are connected vertically, as we can see from here. So in other words, whatever voltage comes here also comes here. And the same applies to this outer strip as well. Now let's come to the center pieces, these two main pieces. So A, B, C, D, E, F, G, H, I, J. These are divided into two sections, A, B, C, D, E and F, G, H, I, J. These 5 pins are interconnected. So in this case, they are horizontally connected. So whatever voltage comes here would also come here. And the same applies to A, B, C, D, E. Whatever voltage would come on A7 would also come on E7. These two are not connected. If you want to connect these two, all you have to do is connect E and F. Perfect. Now let's take a look at our circuit. It's very simple. We're going to control 3 LEDs. To control the 3 LEDs, we're using the pin number 2, 3, 4 on your Arduino board. These are your digital pins, and you're using the ground. Alright, now let's talk about the LEDs. LEDs have 2 terminals, one is your cathode and one is your anode. All the cathode connections would go on the edge or the blue section, and all the anodes would go on these 2 center sections. You can place it anywhere you like. The connection is very simple. You connect 2, 3, 4 to one end of the resistor. The other end of the resistor is connected to the LED. So for example, 2 is connected to the resistor comes here, and this is connected to the anode of the LED 1. Same goes to 3 and 4. Now what is the resistor doing here? The resistor is 220 ohms in value, and this is here to protect your LED. Alright, now let's take a look at the code. I've written a basic program to control 3 LEDs. Alright. In general, there are 2 sections of the code. One is the setup section, second is the main loop section, which runs over and over again forever. In the setup sections, generally you set the pin mode, you are setting up variables, you're setting up libraries, and so on. And whatever you need to do, generally the logic part is in the main loop. Of course, you can have sub-functions and you can call those functions within the loop. Perfect. Now let's come to the setup. In the setup, we are using the function called pin mode to set up the pin number 2 to output. So it's going to behave like an output pin. Do the same for pin number 3 and pin number 4. Now let's go to the main loop. In the main loop, what we're doing is we want to control the LEDs by controlling the pin number 2, 3 and 4. So first we set the pin number 2, 3 and 4 to high. So obviously when you say the pin is high, the LED is going to glow. Now keep in mind that when you set a pin to high, it's basically giving a 5 volt output. Okay. We also want to introduce a delay between this sequence. So first pin number 2 goes high, then there's a delay, then pin number 3 goes high, there's a delay, pin number 4 goes high, then there's a delay. Now what we want to do after this is we want to reverse this pattern. We want to switch off the LEDs connected to pin number 2, 3 and 4. How we do it is by setting the pin to low. Of course, all of these also have a 2-second delay. Now the way to set a pin high or low is by using the function digital write. Then you give the pin number, then you can say high or low. The way to introduce a delay is to call the delay function and to give the time in microseconds. So this is 2000, that means 2 seconds. Alright, now let's see all of this in action. Let's first take a look at the assembly. Now we have the breadboard, we have the Arduino controller, pin number 2, 3 and 4 are connected, and we have a ground connected. On the breadboard, we have 3 LEDs. The anode is connected on this side of the breadboard, the cathode is connected on this side of the breadboard. Ground is going to a common connection and is connecting to all the cathodes of the LED. The anode side is, as we explained previously, one side is going to the pin and via a resistor it goes to the LED. For example, pin number 4, which is the orange, comes here to point number E, and the C, which is a resistor, goes to the LED, resistor goes to the LED, and the LED goes to the ground. Perfect. The same goes to pin number 3 and 2. Now let's go ahead and upload the code onto the microcontroller. Code is compiling. It's gonna load in a bit. Alright, there you go. Now you see that your LEDs are glowing in the pattern you designed them. So each of them is switching on and switching off after a 2-second delay. If you were able to do this, congratulations, you're ready to do more advanced stuff. Welcome to the world of IoT. In the next video, we'll see how to set up a ESP8266 Wi-Fi module for test. This is how you're going to connect to the internet. Thank you.